World War II is often remembered for mass-produced fighters and bombers, yet a parallel aviation effort operated outside standard service categories. Across all major combatants, dozens of experimental aircraft were developed, tested, and in some cases flown under operational conditions without ever entering full production. Many of these designs addressed highly specific tactical problems or anticipated future air combat requirements decades ahead of their time. Archival records show that several post-war aviation breakthroughs can be traced directly to these wartime test programs. This video presents a complete reference catalog of every experimental aircraft tested during World War II, organized by role, technology, and development purpose. Without omission or narrative interpretation, this catalog covers the period from 1939 to 1945, focusing exclusively on aircraft that reached at least the prototype or flight test stage during World War II. The primary geographical scope includes Europe, the Pacific, and associated test facilities in North America and East Asia. Aircraft are organized by functional role and technological intent, rather than by nation alone. To highlight parallel development paths, included are experimental fighters, bombers, reconnaissance platforms, propulsion testbeds, and special-purpose aircraft. Excluded are purely conceptual designs, unbuilt paper projects, and post-war prototypes that began development after 1945. The structure progresses from conventional experimentation toward increasingly radical late-war systems. This section catalogs experimental aircraft developed to address concrete, operational limitations encountered during wartime air combat. The progression begins with modified conventional airframes and advances toward fundamentally new aerodynamic and propulsion concepts. The first group covers experimental fighter and interceptor aircraft developed to counter increasing bomber speed, altitude, and defensive firepower. Germany 1940 for per rocket-powered interceptor. The Me-163 was designed to counter high-altitude Allied bombers using extreme climb performance rather than endurance. Powered by a liquid-fueled rocket motor, it reached operational speeds exceeding conventional piston fighters. A defining feature was its wheeled takeoff dolly and skid landing system, its impact lane proving rocket propulsion viability, while highlighting severe operational limitations. Germany 1940 for per high-speed jet fighter experimental variants. These configurations were developed to reduce drag and increase maximum speed through refined wing suite and fuselage shaping. The designs were intended to address compressibility effects encountered at high subsonic speeds. Wind tunnel and limited prototype testing informed post-war swept-wing jet design standards. United Kingdom 1941 per jet propulsion test aircraft. The 2839 was designed to validate turbojet propulsion in a controllable airframe. Its compact design prioritized engine testing over combat capability. As Britain's first jet aircraft to fly, it directly enabled the development of the Gloucester Meteor. United States 1942 per jet fighter prototype. The XP-59A was developed to introduce turbojet propulsion into U.S. fighter development. Early engines produced limited thrust, resulting in performance inferior to piston fighters. Its primary importance was familiarizing engineers and pilots with jet handling and maintenance requirements. The next group focuses on experimental bomber and strike aircraft developed to increase payload, range, or survivability. Germany 1942 per high-altitude bomber and reconnaissance aircraft. The Z-130 was designed to operate above interceptor reach using pressurization and advanced supercharging. Multiple prototypes tested different engine and pressurization arrangements. Persistent mechanical complexity limited further development. Germany 1940 for per experimental jet bomber. The Ju-287 was designed to explore forward swept-wing configurations for improved low-speed handling with heavy payloads. The prototype combined components from existing aircraft to accelerate testing. Its aerodynamic data later influenced post-war research programs. United States 1946 testing origin, wartime development, flying wing bomber. Developed during the later war years, the XB-35 was designed to reduce drag and radar signature through a tailless flying wing layout. Wind tunnel and glide testing occurred before war's end. The concept demonstrated efficiency advantages with significant stability challenges. This transition leads to experimental reconnaissance and special mission aircraft, optimized for speed, altitude, or unconventional roles. United Kingdom 1940 for high-speed research aircraft. The DH-100A was designed to explore swept-wing behavior at near transonic speeds. Its compact airframe allowed rapid data collection on compressibility and control to program. Directly informed jet fighter wing design. Japan 1940 for high-altitude interceptor prototype. The Ki-94 was designed to counter B-29 bombers operating at extreme altitude. It featured a pressurized cockpit and heavy armament. Development delays prevented flight testing before Japan's surrender. The next chapter introduces propulsion-focused experimental platforms created specifically to test new engine concepts. Germany 1939 rocket propulsion test aircraft. The He-176 was designed to evaluate liquid fuel rocket propulsion in sustained flight. It was the first aircraft to fly solely under rocket power. The program established foundational data for later rocket interceptors. Italy 1940 motorjet experimental aircraft. The N.1 was designed to test a hybrid propulsion system using a piston engine-driven compressor, while not a true jet. It demonstrated transitional thinking between piston and turbojet concepts. Performance limitations curtailed further development. This progression naturally leads into aircraft developed for extreme speed and terminal interception roles, setting conditions for guided and unmanned systems that followed. By the middle years of the war, experimental aircraft development underwent a clear doctrinal shift. Early programs focused on improving existing airframes through incremental changes, while later efforts prioritized radical solutions driven by physics rather than tradition. Jet and rocket propulsion, swept and forward swept wings, and tailless configurations reflected a recognition that piston engine aircraft were approaching practical performance limits. This transition reframed aircraft design as a problem of energy management, compressibility control, and systems integration. As a result, experimental platforms increasingly functioned as flying laboratories, intended less for combat deployment and more for extracting aerodynamic and propulsion data that would define the next generation of air power. The final phase of wartime experimentation concentrated on aircraft intended to overcome imminent strategic defeat or to establish technological advantage beyond the war itself. These systems often combined extreme performance goals with abbreviated testing timelines and unconventional operational concepts. This group begins with piloted extreme interceptor and emergency defense aircraft. Germany 1940 for propulsojet-powered parasite fighter. The Me-328 was designed as a lightweight interceptor deployable from bombers or ground launch systems, powered by Argus pulsojets. It was intended to counter bomber formations at minimal material cost. Severe vibration and structural instability prevented operational use. Its importance lies in illustrating the limits of pulsojet propulsion for piloted aircraft. Germany 1945 vertical launch point defense interceptor. The BA-349 was designed to defend fixed targets using a rocket-powered vertical launch profile. It featured a minimal airframe and disposable propulsion system. Only limited manned tests occurred before the war ended. The concept anticipated later surface-launched interceptor and missile systems. Germany 1940 for piloted guided weapon derivative. The Reichenberg was developed from the V-1 flying bomb to provide a manned terminal guidance capability. It was designed to improve accuracy against hardened targets. Testing revealed severe survivability and control issues, and no operational deployment followed. The program demonstrated the impracticality of manned guidance for one-way weapons. The next subgroup addresses tailless and flying wing aircraft that blurred the line between aircraft and future strategic delivery platforms. Germany 1940 for jet-powered flying wing. The Ho-229 was designed to reduce drag and increase speed through a tailless flying wing configuration. Jet propulsion allowed the design to exploit aerodynamic efficiency. Prototype flight testing confirmed performance potential but revealed stability challenges. The aircraft represented an Early convergence of jet propulsion and low observable geometry. United States 1943 per flying wing test aircraft. DN-9M was developed to validate flying wing handling characteristics at reduced scale. It was designed to inform heavy bomber development. Extensive flight testing provided critical data for post-war strategic bomber programs. This progression leads into experimental unmanned and remotely influenced aircraft, marking a conceptual shift toward automation. United States 1940 for per unmanned assault drone. The TDR-1 was designed for remote-controlled precision strikes against fortified targets. It employed television guidance for terminal control. Limited combat use demonstrated feasibility of faced logistical complexity. Its legacy lies in establishing core principles of modern unmanned aerial systems. Japan 1945 per radio-controlled explosive aircraft. The BA was designed to strike Allied ships using remote guidance. Development remained limited due to material shortages and technological constraints. The project reflects parallel global exploration of unmanned strike concepts. The final subgroup focuses on experimental aircraft whose value emerged primarily after the war through captured data and personnel. Germany, 1945. Pulsajet-powered light attack aircraft. DF-126 was designed as a low-cost, high-speed ground attack platform. Testing occurred under Soviet supervision after the war. The program influenced early Cold War experimental aircraft development. Japan 1945 per rocket interceptor derived from foreign technology. The J-8M was designed to counter high-altitude bombers using licensed rocket technology. Flight testing was minimal due to fuel instability. Its importance lies in the international transfer of experimental concepts under wartime pressure. These late-war systems collectively illustrate a decisive shift from aircraft as reusable platforms toward aircraft as expendable or data-generating systems, bridging wartime, aviation, and post-war aerospace engineering. Taken together, these experimental aircraft reveal consistent patterns in World War II aviation development as operational demands intensify. Designers increasingly abandon incremental refinement in favor of conceptual risk, speed, altitude, and interception capability became dominant priorities, driving experimentation with propulsion, aerodynamics, and control systems that exceeded contemporary manufacturing maturity. Many programs failed in practical terms, yet succeeded as technical investigations. This catalog demonstrates that modern jet aviation, missile systems, and unmanned platforms did not emerge abruptly after 1945, but evolved directly from wartime experimentation conducted under extreme constraints. For those examining the origins of modern air power, these aircraft represent transitional mechanisms rather than historical anomalies.